Now let's see what these four elements are like in our watch. First, we'll take our watch apart, like this. We'll begin with this part, the mainspring and barrel assembly. And so we can see everything that goes on inside, let's use giant parts to make a watch model. This is the mainspring, and it lives inside the mainspring barrel. The mainspring is the power plant of the watch, the source of power, like the faucet in our water clock. By winding the spring, we can store up energy. Here is a winding stem with gears and a click to keep the spring from unwinding. And here is the unit that controls the flow of power, like the nozzle on our hose. It is called the balance wheel and hairspring assembly. It consists of the balance wheel, hairspring, balance staff or axle. Fastened to the balance staff is a part called a roller. To the roller is attached an upright jewel pin. Let's see how these work together. A push on the jewel pin will start the balance wheel moving, and more pushes will keep it moving. To do this job of pushing, we need this odd anchor-shaped lever called a pallet. It can be mounted so that when we move the pallet back and forth, we can apply a series of impulses to the jewel pin to keep the balance wheel in motion. Now to the pallet crossarm, we add a pallet jewel shaped like this. Here is a wheel called an escape wheel, with teeth on it so shaped that they will push the pallet jewel and jog the balance wheel into motion. Now we'll use the energy stored up in our mainspring to drive the escape wheel. As the mainspring uncoils, it causes the barrel to rotate with it. That didn't last long, did it? Let's try it again. Once things get started, there's nothing to stop them. What we need now is a way of holding the power in check, releasing it a little at a time just when it's needed. Another pallet jewel at the other end of the pallet crossarm will do the trick. Just as the first pallet jewel gets a push from the escape wheel, the second pallet jewel locks against another tooth of the escape wheel to hold the power of the mainspring in check. But the balance wheel keeps swinging, and the jewel pin moves the fork end of the pallet until the escape wheel is again unlocked. But when we connect the mainspring directly to the escape wheel, the power is soon exhausted. In an actual watch, it would last only a few seconds. What we need is a way to stretch the power so it will last for more than a day. In our water clock, we used a hose to transmit power from the faucet to the nozzle. We also need a way to transmit power here. So let's add a system of gears and wheels. We'll stretch them out in a line instead of in their usual closely confined location in a watch. Look at the gears a moment and see what they do. First, a small partial turning of the mainspring barrel drives the center wheel a complete revolution. A partial revolution of the center wheel drives the third wheel a complete revolution. and this in turn drives the fourth wheel much further. As a result, a few turns of the mainspring barrel, driven by the mainspring, will drive the escape wheel many, many revolutions, enough to last a full day and longer. What we have now is a complete model watch train. Through the gears, the mainspring drives the escape wheel. The escape wheel teeth push first on one pallet jewel and then the other. The pallet fork nudges the jewel pin on the balance wheel to keep it moving. The swinging balance wheel on its return trip moves the pallet fork. This unlocks the escape wheel to release a little more energy from the mainspring. Back and forth, the balance wheel swings, controlled by its small coiled spring, the hairspring, in perfect rhythm. Each swing unlocks the escape wheel so it can give an extra push to a pallet jewel, and this is passed on to the balance wheel assembly to keep the watch ticking far more steadily than any beating heart. All we have to do now to measure time is count the ticks. But this would be a tedious job and not very practical. Just as we needed a dial on our water clock, here too we need a method for recording the flow of power. So to the shaft of this gear or wheel, we add an indicating hand to measure seconds. As the gear train of a watch moves far enough to make 5 ticks of the escapement, the second hand moves 1 graduation on its dial. To count the minutes, we can attach a dial and fasten a pointer to this gear wheel, which is just the right size so that it turns 1 complete revolution while the second hand makes 60 revolutions. And to count the hours, we can have another pointer geared just so, to move 1 complete revolution every 12 hours. The second hand makes a complete revolution, and the minute hand moves 1 graduation, and when the minute hand makes a complete revolution, an hour has passed. Now we can tell what time it is. But a gear train all strung out like this is a long way from an actual watch. Let's let our model do a bit of rearranging all by itself. Now we know what time it is and how and why we know. A fine watch itself is, of course, a compact precision mechanism with parts miraculously small and fashioned by craftsmen with incredible accuracy.